That's a lot. Here's the one. I don't like the outfit, but I like the they have the outfit. So basically there's show blacks, it's like your own it's a uniform to yeah, wearing.
Oh, sure.
Other side. That's what I forgot because it was like that. Okay. If you weren't here this morning, come up here real quick and I'll hold you the materials. Okay. One more thing. There you go. You're welcome. All right, welcome back, everybody. How was your lunch? Okay.
How was yours?
It was good. Got some things done too. All right, so the rest of the afternoon, welcome to those of you who were with us this morning. We spent this morning going through competencies 1 and 3. So this afternoon is going to be 2 and 4. So if there's anything you have questions on 1 and 3, I'm happy to help. So let's pick up where we were before. I want to go back to the textbook again. So again, those of you who weren't with us this morning, there's a document that I'm calling the textbook. It says GKT Mathematics Preparation GKT Bootcamp on it. All right, new .cam, just figure out how to do this. Okay, cool. So it says textbook now. So what I want you to do, let's see. Does that help at all? Yes.
Sure.
Yeah.
I think there's too much lighter. Okay. So we're going to focus on 2 and 4. So there's a couple things. Actually, there's more on 2 and 4 to point out than there were on 1 and 3. So let's go first to page 6. So starting on page 6, we're getting into geometry. So starting on page 6, first you're getting into types of quadrilaterals. This is a portion, like I was talking about this morning, where there's like vocabulary and then there's also kind of logic. This is a heavy vocabulary area. So I suggest you go through this and really kind of study the different types of quadrilaterals because there's some questions, we'll see, we'll do those in a second, that really get into helping you sort of distinguish specific quadrilaterals based on category, like characteristics. Yes. Page 6. So talking about how many sides, sides, the angles, what are they congruent, are they not, all that kind of stuff. So here we talk about quadrilaterals. So you've got parallelograms, rectangles, rhombus, square, trapezoid. Page 7 gets into talking about angles, like classifying types of angles. So again, more vocabulary. So like an acute angle, those are the angles that are less than 90 degrees. Right angle, we talked about some of those this morning. Angles that are equal to 90 degrees. Obtuse, the ones that are larger than 90, but less than 180. So more vocabulary again. Go to page 8. On 8, now you've got triangles. So classifying triangles, we've got scalene triangles. Those are the ones that like all the sides and all the angles are different. My students, when I taught 6th grade, whenever we did this geometry unit, I would have them do a foldable. Like I had them fold a piece of paper into 4 parts. They would have to write the word, the definition, draw some sort of picture, and give some sort of real world way to remember. And a lot of them remembered scalene because they would just say, it's a weird word, it's just a weird triangle. It's a triangle, but nothing's the same. So scalene, those are the ones that none of the sides, none of the angles are the same. For isosceles, a lot of them would say isosceles looks like an ice cream cone or like an icicle. So remembering the shape to remember that 2 sides in an isosceles triangle and two angles. So these 2 angles are the same and the 2 sides are the same. And then equilateral just sounds like the word equal, equilateral, equal, all sides, all angles are the same. And one thing that I did not put in here, but I wanted you to write, is remembering that all angles of a triangle add up to 180 degrees. So 180 degrees is actually a straight line. And you can actually prove this with kids. Have them draw any triangle, cut it out. If they tear off all the angles, they actually fit in and line up to make a straight line. So you can tell them they all equal 180 degrees and they can actually prove it. Anything you can do hands-on with kids helps them kind of solidify their learning and really be a part of it and thinking about it. So this is one thing I did with triangles. Go to page 9. 9, you've just got different types of things now. Acute angled triangles, all of them are less than 90. Right triangle has a right angle. Obtuse triangle, one is greater than 90. So that's kind of a very heavy section of vocabulary. So I really suggest you look over the quadrilateral part and remember like the rules of triangles, because that'll help you in the geometry and measurement section. Okay, let's go to page, that's all of competency 2. Let's go to competency 4, page 25. On 25, you start getting into the data interpretation. And notice how this particular skill says analyze and evaluate how the presentation of data can lead to different or inappropriate interpretations in the context of real world situations. So they really want you to get into that. Like, and one way to think about it is think about like advertising. If someone's advertising something, like they're printing some sort of graph or chart or anything like that, they obviously want to sway you to buy or believe or whatever it is. And they're not lying about what they present, but they can skew things. So I want you to make sure you're paying attention to things like, what are the axes? So like on the y-axis, what is it going up by? Is it going up by 1? Is it going up by 5? Is it going up by 10? You can skew data by changing those. Also, notice the first thing I suggested, and I said that this morning, anytime you have any sort of data that has units in it, so you're talking about grams or kilograms or inches or feet or whatever, just do a mental note to make sure, are all of them the same? Or if the answer choices are in feet, but my problem is in inches, just take a mental note of what the different units are, so you know, do I need to change my units? Do I need to pay attention? Like for instance, when I took my test, it had a question where it was wanting to know which of the following had the greatest increase or something like that. And there were 4 charts that were the answer choices. And I quickly was looking at them and I just looked at the numbers. And I noticed that the last 2 had the same numbers. And I was like, well, wait, that doesn't make any sense. And then I noticed 3 of the 4 were in pounds and the last one was in kilograms. So they try to throw in little things like that. So I had to understand, oh, okay, take note that they're not the same. Like look, for instance, at number 67. And it's not all on one page, but if you look at the first thing, so I just created something in Excel. I said, let's pretend that this person has these sales in their car dealership, and the y-axis, notice it's going up in here by 50, number of cars sold every year, so you kind of see it. If you flip to the next page, what I did, I took the same data, I just changed the y-axis. So in this particular one, it doesn't even start till 130, and then it's only going up by 20. If you look at C, it has starting at 0 going up by 100. So you kind of see this particular question. I said, which one shows the most, what is the question? Let me go back to it. Which of the following graphs shows the greatest increase? So they might use this one to say, hey, look at Ron's auto sales. We're doing amazing. There's been such an increase. But then you realize it's the same data. If you look at it this way, it's almost a flat line. So they've skewed the y-axis to kind of help you see, oh, that looks like it's way better. So taking note of that and how they do that, because actually the answer is D. All of them are the same. It's the same data. It's just the axis has changed. So taking note of how they can kind of skew the data to make it interpreted one way versus the other. I don't understand this because, oh, there are some. The other room didn't even have any expo markers. I'm like, well, don't trick me and tell me there's expo markers. This is very strange. There aren't any. This is not a marker. Doesn't it look like it?
Yeah.
It's a very
picture.
It's a picture. It says only expo dry erase markers are permitted for use on whiteboards. Need more? Contact your department scheduler. Who's the department scheduler? So yeah, this is a picture. No markers there.
Oh my god.
It's like an optical illusion, huh? Anyway, let's turn to page 28. I think it's just an advertisement from Expo. Let's just look at it.
That's what I actually think.
So look on page 28. In 28, we're talking about central tendency. And you're going to see, if you've taken the GKT or you've done some practice already, it talks about measures of central tendency. And what they're really talking about when they're talking about the measures of central tendency is basically, yes. Oh, more of these? Yes. If you missed them this morning. Anybody else have it?
I just can't find it.
Oh. It's the one. What page is this, everybody? 28. Yeah, that's what that is. So, measures of central tendency are just what they sound like. They're really just saying, how is the data distributed? So, are we talking about data that's very, very close together? Are we talking about data that's spread out? All that kind of stuff. So, these are some of the main ways of looking at and analyzing measures of central tendency. Mean. Most people know the mean. The mean is the average, right? And you guys have been through school enough to know, everybody knows how to calculate their grade. Add up everything and divide by how many there are. You look at that a lot. So remembering that the mean is the average. The median, most people don't have a problem remembering it's the middle number, but making sure you're ordering the numbers from least to greatest. So you all remember, like this example down here, putting them in order and crossing them off till you get to the middle. What happens if you end up with 2 in the middle? Add them together and divide by 2. So you want to find basically the average of those two. The mode is the one that occurs the most often. So notice the highlighted words. That's kind of how my students helped. They're like median, middle. So longer words start with an M. Mode, most, both start with M-O. But remembering it's the most often, so the one that's repeated the most. And then range, the difference between the largest and the smallest. You all hope you get like a range question. Super easy. So remembering measures of central tendency. So again, this is competency 4, right? Remember what I said before this morning, if you weren't here, the test follows the competencies in order for the most part. So toward the end of the test, you're getting into competency 4. These aren't hard concepts. They're just things that could take you a little bit of time. So that's why it's important that you mark and move on. Like if you have a question you don't know, mark it, move on, get the ones out of the way you do know, and then go back and have time. Because then when you get to these questions, you have time left. So you don't want to get to the end, you've run out of time, and now you don't have time to calculate the mean or the median or anything like that. But they're easy questions. So central tendency. Take a look at page 30. Okay. Anybody else their throat is sore from like the allergies? Like it's dry and it's not dry and it's just like my eyes are itchy and my throat is sore. I promise it's just allergies. But right now, just talking, I'm like, oh, I need some water. So standard deviation. How many of you have taken statistics? Okay. So the statistics on the GKT is not like that. You're not going to be calculating Z-scores and T-scores. What the heck is a Z-score and T-score and why is it useful? I don't know. I took statistics in college and I understood because I could do algebra, but I didn't understand why. I was like, why am I calculating Z-scores and T-scores and what do they even mean? And the variance, like all that kind of stuff. My professor was really interested. I was actually at UCLA taking a class. I just went out there for a summer, just back then. I don't know if they still do. You could take classes for the summer at UCLA, and they charged in-state tuition. So it's cool. One of my college roommates and I just went out to California for the summer. Had fun. But anyway, he was a 6-week class, and he was like an anthropologist, and he was talking about all his digs and stuff. So it was like Indiana Jones teaching me my statistics. Still don't really understand why Z-scores and T-scores, but it's a fun class. But anyway, in terms of the GKT, for standard deviation, you just have to understand what it is. That standard deviation is basically what it sounds like. How does the data deviate from the standard? And the standard being the mean. So basically, how widespread is the data? If it's a low standard deviation, and you'll know when we talk about like a normal distribution curve, there's only 3 standard deviations. So if it's a low standard deviation of 1, that means everything's very close to the mean, like it's very condensed. But if it's a high standard deviation of 3, that means it's very widespread. So standard deviation just tells us how does the data deviate from the standard or the mean. So we'll do one of the questions, and one of the practice tests actually gives that standard deviation curve, and I can do that one, so I can show you that. But just knowing standard deviation, basically how spread out is the data. A low standard deviation means it's very, very condensed. A high standard deviation means it's spread out. Page 31. This is key. See, this is a standard deviation curve, so we'll talk about that later. An outlier. So what does an outlier, what is it and how does it affect the data? So the key to remember, an outlier is just what it sounds like. It lies outside the data. Bless you. So whether it's really, really big or really, really small, it's an outlier. So if you're talking about, say you're talking grades. So you're doing pretty great in the class. You're doing well. You've got like A's and B's on everything. Now think it's like a high school class or middle school class, not college, because typically in college you don't have very many assignments. So say you're back in high school, you're making all A's and B's, and then something slips your mind and you don't turn something in. So you get a 0. What happens to your grade? It drops pretty significantly, right? Because if you're getting A's and B's, your average is staying around an A or a B. But then you get that 0 and it drops. That 0 is an outlier. And an outlier always affects the mean or the average the most. So if you start kind of training yourself on remembering an outlier and getting used to, if you're looking at data, if there's an outlier, so if it goes maybe the other direction, so you're going to see some examples where it talks about how can this store advertise, they might say the average salary of people that work for us is $45,000. But they're taking into it, but most people make about $20,000, but they're taking into account the 2 CEOs or upper management that are making 100 plus. So those outliers are impacting that average and skewing the data. So just start kind of training yourself in the GKT. You notice there's an outlier, be prepared that it's probably going to impact the mean. It's like a jungle in here with all these chords and okay, let's move on to page 33. There's a lot of different random things on 33. I haven't looked at this in a while where it doesn't have all my chicken scratch. Okay, so the probability part is new. So this is a tree diagram. Do you guys remember doing those when you were a kid? Is anybody really, so tree diagram, as you see, and this, the way you read it, they're saying they tossed a coin 3 times. The first toss, they had the choice of heads or tails. Then going from each one, they had heads or tails, and then going to the third one, heads or tails, off of each one. So it shows the tree. In that last column, you see it says outcomes. Tree diagrams are helpful as an organized way to show all of the outcomes. So if you want to know what are all the possibilities of flipping a coin 3 different times, you get heads, tails, heads, tails, and so forth. So in this particular question, they're wanting to know, use that tree diagram, find the probability that exactly 2 of the 3 coins will land on heads. So you'll notice I put check marks. Only 3 of the outcomes have 2 heads. So probability, and I wrote that there, is the number of favorable outcomes over the number of possible outcomes. So it's the number of times whatever you're looking for happens over the total. So in this case, the probability of that occurring is 3/8. So that's the tree diagram and how you use it to answer that question. So tree diagrams, helpful if all you want to know are if you need to analyze the outcomes. There's something else called the counting principle. So we go toward the bottom, where if it doesn't really matter what the outcomes are, like you don't need to analyze them. And all you want to know is how many are there, then you would use what's called the fundamental counting principle. So that's what this is, the counting principle. So it's the number of choices for whatever the first stage times the number of choices from the second times the number of choices from the third and so forth. So like on this example in number 84, how many different combinations are there if you flip a coin, roll a 6-sided die, and then flip another coin? So there were 2 choices, heads or tails, times 6 choices, 1, 2, 3, 4, 5, 6, times 2 choices, heads or tails. So there are 24 different combinations of doing those 3 things. And notice on 84, all they wanted to know is how many outcomes. It didn't matter they didn't say, what's the probability of getting a heads and a tails? They didn't ask that. Now you'd want to do probably something like a tree diagram if something like that mattered because you'd want to know what the outcomes are. But if all they want to know is how many outcomes, counting principle. Like number 85, classic kind of problem of like making a sundae or making a sandwich, all that kind of stuff. How many outcomes, counting principle. And that's another really quick question if you get one of those. Like I think there's one about like, how many different outfits can he make if he has 5 shirts, 2 pairs of pants, and 3 pairs of shoes, or whatever like that. So choosing how many outcomes there could be made. All right, the last page on here before we move into the problem. Page 34. At the bottom of 34, we have kind of a specific rendition of the tree diagram. Of the counting principle. How many of you took finite math or math for liberal arts? So you did like combinations and permutations. Mm-hmm. Now you don't have to actually do a combination and permutation for these, but you'll probably recognize that 4 and then the exclamation point. Do you remember what that's called? What's with the F? You don't have to know what it's called, but I just want to know if anybody remembers. It's called a factorial. Is that what this is? So what this is, if once you choose something, you can't choose it again, then you would use this sort of idea of the counting principle. But like in this case, if you're talking about, in this one, 4 children finishing in a race, there can't be a tie. So there's 4 places. There's 4 choices for the first place. But once someone finishes first, they're not in the race anymore. So now there's only 3 people. Once someone finishes second, now there's only 2 people. And that means there's only 1 person left for the last place. So there's 4 times 3 times 2 times 1, 24 different ways a race could end with 4 people. Like number 90, how many ways can you put 5 books in order on a bookshelf? I think maybe on the GKT when I took my test, it was like trophies. How many different ways can you put 5 trophies on a bookshelf? Once you put 1 book up, so there's 5 choices for the first book, then you only have 4 books left, then 3 books, then 2, then 1. So there's 120 ways you could put 5 books on the bookshelf. Now you could sit and try them all out, but that would take you a really long time. Like you could write A, B, C, D, E, A, C, B, D, E, whatever I missed. So you could write them all out, but 120 ways, you'd probably get lost. So just remembering, kind of like that counting principle, but once you use something, you can't use it again. Okay, questions? Those of you who have taken the test before, do you remember a question like that where it was like, how many ways can you put books or trophies? Like I remember on mine, I had trophies. I actually had one on mine that was like number 86 at the top here. You had the letters. I had 5 letters. How many ways can you choose 3 letters if the letter C must be there? And in this case, I say sometimes it's easier just to write them out. Because I started on this one trying to figure out like combinations and all that kind of thing. Choose this many if you can only have 3. Then I realized it's easier just to go A, B, C, A, C, B, A, C, D, A, C, all that kind of stuff. So, and we'll get into probability. I'm going to do a problem that talks about compound probabilities. Any questions or comments? I know I just kind of flew through that, but I wanted to get that information, and now we can do some practice problems. Okay? All right. So we are heading back to the mathematics subtest one. And you'll notice you have at least 2 other practice tests that you picked up this morning. I didn't make more copies of practice of the ones from the 3rd edition of the book. So any of you that were here this morning, you probably took my last copies of that. That's okay. But everybody has at least 2 additional practice tests that they're taking home with them. And those are from the 4th edition of the REA book. It's a blue book, if anybody has it. But now, going home, you have 2 additional practice tests to help you practice. I suggest maybe you go and you take one of them. So if you notice on those, they have numbers written off to the side, like 1, 2, 3, or 4. That's the competency that particular question it covers. So I suggest you take one of the practice tests that I gave you, maybe take it as a practice test for yourself, like a diagnostic test, and get a feel for which areas do you need to focus your studying most on. And then I'm going to send you those homework packets. You're going to have some homework that I send you so you can kind of practice those. Okay, so those of you who were not here this morning, we went through the ones that have competency 1 or 3 next to them. So again, if you have questions, I'm happy to help. So we're going to go to page 3. I wish there was a way to like turn this. And I know I tried that last time. Because I'd like to stand like this. I'd like to float out here in space, but it's not happening. Is that just like gonna be a disaster waiting to happen? Yes. Deanna's gonna break all of the stuff in the 317. All right, anyway, here we are, number 7. A building 51 feet tall casts a shadow 48 feet long. Oh, yay! The shadow and building problem, or the tree and shadow problems. You're probably going to see one of these on your test. Did any of you guys remember learning this when you were a kid?
Yeah, but I don't remember.
Yeah, so like I remember, and when I taught it, like going outside and actually doing it, saying like, all right, there's a flagpole and we can measure the shadow and we can measure our own heights and our own shadows and we can figure out how high is that flagpole. That's what this is. It's similar triangles is what it is. So I'm just going to draw it. I'm going to say, okay, I've got a building and my building is 51 feet tall and its shadow is 48 feet. I'm just going to drew a little triangle. It doesn't really matter, but it's a right triangle. Okay. So I got my building, got my shadow. I've also got a statue. And the statue is however tall it is, and its shadow is 16 feet. And we want to know how tall is the statue. Now, I'm going to do a quick thing in my head of like, okay, everything's in feet. Are the answer choices in a unit? They're also in feet, so we're good to go. We don't have to change any units. Okay. There's something called a proportion. A proportion is two ratios, so fractions are ratios, set equal to each other. And in a proportion, the cross products are the same. So I'm going to set up a proportion. And I'm going to teach you how to do it, how to set it up, but then I'm going to show you a shortcut. I would say if you are able to set up proportions, you can probably get about, I would say 30 or 40% of the questions on this test by doing a proportion of some sort. It's helpful if you're setting up the proportions that you're writing them, like I always say, write it in words first. So I'm going to talk about the building and the statue. And then this is going to be the height over the shadow. So if I keep track of it in words first, I'm not going to mess up where I put my numbers. I mean, if you kind of look at it, it's already in a fraction. You already have 51 over 48 equals x over 16. But writing it in words, so if you didn't even draw them, you know, okay, the top number on the left fraction is going to represent the height of the building. The bottom number is going to represent the shadow of the building. Here's the height of the statue. Here's the shadow of the statue. So now I have a proportion. Two ratios, so two fractions set equal to each other. The cross products of these ratios are equivalent. So as long as I know 3 of the 4, I can solve for the 4th. So I can say 51 times 16 is equal to 48 times x. Now I don't have my calculator out, so somebody help me out. 51 times 16, what do you get?
816.
Or what?
816.
816? Okay, 816. And then 48 times x is 48x. Now we're just solving for x. So what happens when you divide by 48?
17.
17. So the answer is 17 feet. All right? Now, using this same problem, I'm going to teach you a really quick shortcut. So obviously, if you want to go through this whole process here of solving it, you know, writing it all out, do it if you need to. But here's a shortcut. If you know 3 of the 4 things, you can cross multiply. You can multiply the 2 that are diagonal from each other and divide by the 3rd. So 51 times 16, you can do it on your calculator. 51 times 16 divided by 48, and you're going to get the answer. So you don't have to write out all of this work here if you remember this shortcut. And it works with anything, as long as it's a ratio and a proportion, so you know they're proportionate. Multiplying the 2 that are diagonal, it could be the 2 that are like they are, it could be the 2 that are like this, it could be any of them. Multiply the diagonals and divide by the one that's not in a diagonal. So it could be any of them as long as you have 2 out of the 3. As long as you know 3 out of the 4. Questions? Okay, good. So that's just a shortcut. If you have to, go ahead and set it up the other way. All right. Number 8. Look at all these drawings. What do you think I'm going to do? If I read a rectangular animal pen, what do you think the first thing I'm going to do? Draw it. I'm gonna draw a rectangle. So I've got a rectangular animal pen with will be built using 200 meters of fencing. So what does that represent? 200 meters of fencing. That's the perimeter. So I've got a rectangle. And I know that the perimeter is 200 meters. Keep my units. If one side of the rectangle is 60 meters, find the area of the pen. So it doesn't really matter which one I put where. I'm just going to put it here. I don't know if it's the width or the length. It really doesn't matter. So I'm going to put it there. So if that side's 60, what's this side? 60. And then what's this side? Do we know? 40. Well, you can add it up. But if we don't even know that, what is it? We could just say X, right? Right? I mean, yeah, you can think about it and go, oh, it's going to be 6 equals 6. But let's go through. That's good because you just did it in your head. It is 40. But look at this. If I just put X, they're the same, right? And I say 60 plus 60 plus X, so 2X equals 200. I have 120 plus 2X equals 200. Oops, equals. 120, 2X equals 80, divided by 2. Like you said, X equals 40. So this one is 40 meters, and this one is 40 meters. Let's look at the answer choices. Is 40 there? Oh, wow, they didn't trick you. I was prepared for them to trick you. Be prepared that they might put 40 as an answer. Because now you've found one of the lengths. Okay, so now what are they wanting us to do? The area. So how do I find area? Area is length times width. 40 times 60 is 2,400 meters squared. Make sure you're paying attention down to the unit. On some of the practice tests I've seen, they had 2,400 meters squared and 2,400 meters cubed. So we got excited. Oh, there's a number, ready to circle it. And someone was like, oh, wait, it's there again. And then you're like, oh, you got to actually pay attention to that. So just get yourself trained to really just pay close attention to the units to make sure you're not making a little mistake because of the units, because the GKT is trying to trick us. All right, number 9. Okay, now we're talking about back to those definitions of quadrilaterals. Let's all look at that again. What page is that? 6. 6? Okay. Going back to the textbook, looking at page 6. So a quadrilateral is just a 4-sided figure. Any 4-sided figure is a quadrilateral. When they get to these questions, they're wanting you to get as narrow as possible. It's like whenever like a jury has to go beyond a reasonable doubt, like you have to be able to say that is the actual shape they're talking about to the closest you can get. Yes, they're all quadrilateral. So the answer could be, it is a quadrilateral, but it says must have perpendicular diagonals. Not all quadrilaterals have perpendicular diagonals. What does perpendicular mean? They meet at a 90-degree angle. So if you think about them, you've got a parallelogram, which looks like that. I always think of a parallelogram when I was helping my kids remember. Parallelogram is like a rectangle that's been blown over by the wind. So you got a parallelogram. You've got the diagonals. Okay. You've got a rectangle. And you've got the diagonals. And a rhombus is like a square that's been blown over by the wind. So which one has perpendicular diagonals? I didn't do the best job of drawing. Which one is the only one? Are these perpendicular? Well, my drawing is bad. I'm doing this. Does that make a right angle? Perfect right angle? Let me draw it again. The answer's no, but I can do the best job of drawing it. Now you can see. Are those diagonals making a right angle? Are these diagonals making a right angle? Yes! Can you see it? Or is it just me? My drawing is bad. Rhombus, they should all be the same size, so it should be a rhombus. But that also just goes down to understanding the definitions or like the characteristics of them. So the only one that must have a perpendicular diagonal is a rhombus. Now a rhombus is also a parallelogram and a quadrilateral. So it's kind of like that a rectangle is a square, but a square is not a rectangle. Or sorry, a square is a rectangle, but a rectangle is not a square. So getting down enough to knowing what those definitions are. Okay? Questions? All right. Sorry, my poor drawing skills. You can get out my ruler and everything. All right, number 10 also is talking about the geometric figures again. Okay, so we've got we have to figure out this one. We have a quadrilateral, so we know how many sides does it have? 4 sides, quadrilateral. Are all of those quadrilaterals? No, we can get rid of triangle. Right off the bat. Triangle is not a 4-sided figure. Diagonals that bisect each other. What does bisect mean? Bi meaning two. So a bisection means it breaks them, it bisects or meets exactly in half. It cuts them in half. So their diagonals cut each other in half. And it has at least one right angle. So, now it just says at least one right angle. But let's just draw a trapezoid then with one right angle and see. You got a trapezoid, that's a trapezoid, right? If I did the diagonals, do those cut each other in half? No, so I can say it's not a trapezoid. So it's either rhombus or rectangle. Does a rhombus have a right angle? No. So that's the answer is? Right? Do we agree? So you just kind of have to narrow it down. But in order to narrow it down, you have to know enough about those quadrilaterals to know how to narrow it down. Okay? Number 11. I like geometry. I like this kind of geometry. I don't know about proofs. Actually, I liked proofs. Did anybody else in here like proofs? Did you dislike proofs? You're like, why do I have to prove it? I can look at it and tell you. Why do I have to prove that those two are equivalent? Because you have to go through the whole thing like, this side is the equivalent to this side, and this side is the equivalent to, and then you get like, but, and therefore, ... By side, these ain't, loved it. Because it's all organized. I love organized things. Anyway, sorry. Here we go. Which of the following best describes the faces for the following figure? What's the face of it? What's the face of a 3-dimensional figure? I like that this guy's sitting right here. What's a face of it? The side, like the parts that are facing out. That's the face. So if you picture this guy, Now, some people like to picture it as like facing down, like taking that rectangle that you're seeing and putting that as the bottom. If I put that rectangle as the bottom, what does it look like? Like a roof almost, right? If you're looking at it like that. So they want to know, does it have 2 equilateral triangles, 1 square, and 2 rectangles? Does it have 2 equilateral triangles, 2 squares, and 1 rectangle? 2 isosceles triangles, 1 square and 2 rectangles, or 2 isosceles triangles, 2 squares, and 1 rectangle? What do you want to look at first? The triangles. Okay. What is this face that I can see right here? Well, that's like facing me on this side. What shape is that? First, we all agree it's a triangle. What kind of triangle? It is isosceles. Because it has, remember, isosceles, an icicle, 2 are the same. What is this one if those are 45? Just put it in there, just because. This is a 90 degree. So this is isosceles, and therefore there's one over here on this side, right, that also is isosceles. So 2 isosceles. So they're not equilateral, so it's not A or B. So now we have, what do we know about side A? Well, what do we know about this side and this side? Are they the same or different? Same. These are the same. So, okay. That means if that's an A, this is an A, it's the same, right? So what shape do we have? Obviously, we have a rectangle in the front, right? That's a rectangle, so at least 1 rectangle. So now we have to decide, are there 2 rectangles or 2 squares? What's back here? A square, right? Because this is also A. So this back one is A by B by A by B. So we've got a square back there. And what's on the bottom?
A square.
A square. So we've got A. So we have 2 squares and 1 rectangle. This one's tricky if you're not able to visualize it. I think I've always been pretty good at like Ask my boyfriend though. He says that I struggle with the 3rd dimension. I'm like, whatever, I do not. I run into things. But I can tell. But I can visualize what that shape looks like if I were to move it around and around. You kind of have to do that. Bless you. To think about it. Yes, ma'am. Equilateral is a triangle where all the sides and all the angles are the same. Isosceles has 2 sides or 2 angles the same. You're welcome. Okay. Number 12. Now we have to understand kind of the relation between millimeters, centimeters, meters, and kilometers. So, and if you need to, remember the other practice test, that last page of any of the other practice tests is the reference sheet. On the back of the reference sheet, you have the conversion factor. So you can see relative size. How big is a millimeter? How big is a centimeter? How big is it? Yep, you'll get that. You'll get one of those. So, we've got a refrigerator. In terms of size, millimeters. Are they really small, really big? What are they? Really small. Millimeters are the smallest, right? And then what comes next? Centimeters. So, would it make sense that you would say a refrigerator is 2 centimeters high? No. Unless you were like an ant. So let's go to the top. What's the biggest then? Kilometers. So kilometers are similar to a mile. What is it, 1.6? 1.6 kilometers in a mile. So they're a little longer than a mile. So would it make sense if your refrigerator was 2 kilometers?
Yeah.
Yeah, huge refrigerator. That would be very cost effective. What are you gonna do? Run? I guess if you're gonna have to run 2 miles to go get something out of your refrigerator, then you're getting your exercise. So in this case, what is it? 2 meters. 2 meters. So you don't have to know what the exact size is to be able to answer this. You just have to know what they are relative to each other. We're not asking you to go measure a refrigerator, change it into meters, whatever it is. All right, number 13. Which of the following is the best estimate of the height of a mountain? C, kilometers. So you're not going to say the mountain, again, if you're an ant, maybe. But it's not millimeters, meters, or centimeters, so.
Can the whole test just be this?
I know, I hope so, right? Well, you know, I haven't taken the test in 3 years. I'm actually able to go take it again. Jordan did some research and found out that if you've passed it, you can't take it for 3 years. Which makes sense, why would you want to take it again unless you're doing research like I am? So I want to go take it again. But if this practice came from their website, so if that's any indication of what they're saying is on the test, if this came from the FTC website, then there should be some of this on it. Yes, ma'am?
I've taken it recently and I don't remember
Any of it? Well, maybe there will be. We hope so. Well, there's a third one then. Actually, no, this is different. Okay, now we're talking about yards. Okay, how many square yards of carpet are needed to completely cover a rectangular floor that measures 15 by 9? What do you think the first thing I'm going to do? I'm going to draw it. So I'm going to make my 15 by 9. Now, oops, well, I guess some people like to do this. Now, what are the units that they gave me? 15 by 9 what? Feet. And they want the answers in what? Yards. Always, always, always change your units first. So, because if you go ahead and multiply them and then try to change the units, you actually need to change by a factor of 3 squared instead of by 3 if you wait and do it once it's the area. So change your units first. So how many feet are in a yard? 3 feet is 1 yard. So if I have 9 feet, divide by 3, so it's 3 yards. If I have 15 feet, divide by 3. And I just want to know what? How many square yards? So we just do area equals 3 times 5, so 15 yards squared. Double checking they all have the same units. Easy enough, right? Yes.
I know there used to be like in equation form how to do it. I know that's how they taught me, like to do conversion.
Oh, yeah.
So like, how do you know that you have to divide it by 3 like straight?
I guess just intuitively, knowing that for every 3 feet, it's 1 yard. So I know how many 3s go into 9 and how many 3s go into 15. You could look at, here's the conversion. So if it's 9 feet, right? You're going to multiply it by the conversion, or sorry, divide. Remember this? And then you cancel out the feet. So now you have 9 over 3, which is 3. Yeah. So that's or you could think of it as a proportion too. I think I just do it intuitively. But you're right, that doesn't always come intuitively. Okay, number 15. A 3-foot wide A 3-foot wide wood deck will be built around a rectangular shaped pool that measures 15 feet by 30 feet. The resulting shape is also a rectangle. Okay? If the lumber costs $10 per square yard, what is the cost of the wood for the deck? First things first, we need to draw it. So first we've got the pool, right? So we've got a pool that's 30 feet by 15 feet. They have a 3-foot wide deck built around the pool in all directions. So here's my deck. This is the one that the last time I did this, I had a lot of discussion about. Let's get the dimensions of the deck now. Because my thought is, we're gonna get the dimensions of the deck, and we're gonna find the area of the deck, and then we're also gonna find the area of the pool, and we're gonna subtract the area of the pool from the area of the deck to find how big of the deck is. Does that make sense? Does that meet with like what you would think logically? Take the deck and subtract the big hole that you put in the middle of it. So if it's 3 feet out from each side, how long is this whole part? If the pool itself is 30 feet, plus 3 plus 3, what is the whole thing? This is 36 feet. What about this part? If this part of the pool is 15 and we've got 3 feet here and 3 feet here, what is this long part? 21. Okay? So we have a deck that is 36 feet by 21 feet, and we have a pool that is 30 feet by 15 feet. And we're essentially going to subtract them. All right. What do I need to know before we even figure out the price? Look at the question. What is it telling us?
Should we convert to the yard?
The question is, because why are we converting yards?
The lumber costs $10 per square yard.
So they're telling us the cost of the lumber per square yard. So we need to figure out how much lumber we need in square yards. So, again, just like before, if we're talking about feet to yard, for every 3 feet, you're going having 1 yard. So we're going to just divide everything by 3. So my deck is now a 12, right, by 7. And my pool is now a 10 by 5. Are we with me to there? Good? All right, keep on going. So now what's the area? 12 by 7 is, what, 84? Yeah. And 10 by 5 is 50. So I now have, can subtract them, right? Do you understand why we're subtracting it? Because we've got the area of the deck, 84, but that's the whole area of the deck. And we need to subtract now the area of the pool because we only want the deck. Obviously, we're not putting wood on the pool. I guess you could make a cover. We're not making a cover. We're just putting a deck. So if you subtract them, how much is left? 30. So we have 34 yards squared, which is the actual deck we need to make. Okay, are we done? I'm surprised they didn't somehow put 34 as an answer. Okay, so now we know that we're going to build a deck that is 34 square yards in total, and we have $10 per square yard. So then how much are we gonna figure out how much it costs? Multiply by 10. So we have 34 times 10, which is $340. And this is a very real world problem. Someone might do this all the time. If they're gonna build a deck around their pool in their backyard, easy. And they wanna get an estimate of how much it's gonna cost them. So real world things. All right, let's keep on moving. Where's my 16. All right. A teacher covered the exterior of a rectangular prism-shaped box. What's a rectangular prism?
Box.
Like a box, like a shoe box. A shoe box is a rectangular prism. Prisms are named based on what their faces are, so they're lateral faces. So if it's rectangular, that means they're rectangles, and the sides they're named for what their bases are, so the ends. Their lateral faces are always rectangles. So a rectangular prism is just a box. In this case, since they're not all the same size, like this would be a square prism, or actually no, this is rectangular because those are different. So this is a rectangular prism. Pyramids are named for their bases. So like a rectangular pyramid has a rectangle on the bottom, and then the lateral faces are triangles. So rectangular prism is just a box. So the teacher is taking a box that measures 8 inches by 9 inches by 10 inches, and she's going to wrap it with a piece of wrapping paper that she has that's 2 feet by 3 feet. There are no gaps or overlapping paper. How many square inches of wrapping paper are left over? Now, we have to assume in this question that the teacher literally cut out a rectangle and glued it to it. She didn't do how we always wrap a present, you know, like you have the overlap on the side, and you don't have to figure all that out. That'd be it. We're not figuring all that out. We're just assuming she's just covering. Okay? So don't get too difficult. They should have done something different, like just painting it or something, but then you'd have to get into usage of that. So anyway, we've got a rectangle that is 8 inches by 9 inches by 10 inches. Now, I'm going to attempt to draw it. My 3-dimensional drawings aren't the best. I'm not an artist. But I'm going to say this is 10, this is 9, and then we're going to go back. So, and this is 8. Okay, so that's my box. 9 by 8 by 10. And I have wrapping paper that is 2 feet by 3 feet. So what's the first thing I maybe want to do? Change to inches. So let's change our wrapping paper to inches. Now, how many inches are in a foot? 12. So I multiply both of these by 12. So I have 24 inches by 36 inches. So let's go ahead and figure out how many square inches of wrapping paper I have. What's 24 times 36? What is it?
864.
864. Okay. So I have 864 square inches of wrapping paper. So if I can figure out how many square inches of the box I need to cover, I can subtract that from the square inches of wrapping paper to see how much wrapping paper is left. Now it's going to be in a weird shape, like it's, no one wants it. It'd be like really, really frustrating someone you know by like cutting out a big square in the middle of the wrapping paper and rolling it back up and putting it in the closet. They go the next Christmas to wrap something and they're like, what happened? My family does that. Like they'll put like a little strip like this big back. My sister's like, well, you could have a small thing. I'm like, You unroll it, and you're like, well, what's this? I can't use this. Yes,
Where's the 12 come
because there are 12 inches in a foot. So we changed our feet to inches.
from?
Okay, now in your reference sheet, there is a surface area formula. I don't like using it. In terms of surface area, me personally, and when I would teach this to my students, instead of them trying to memorize some sort of formula and follow some sort of formula, I would have them just pretend that you wanted to build this box. What would you need to build it? You would have this rectangle and this rectangle, right? This one, and then one on the top and one on the bottom. So if we think about what we're building it, all the different sides, and just find the areas of those and kind of put them together, that's the surface area. Because what's the surface area formula? What does it say? I haven't even looked at one for a long time. It's on there, right? Prism equals the sum. Oh, okay, so it didn't give you a surface. Okay, good, it doesn't give you a formula. It just tells you what? The area of all the bases, right? Okay, so we've got this front rectangle, right? What are the dimensions of the front one? 9 by 10. So we have a 9 by 10. We're going to call this the front and in the back as well. So we're going to say the front one is 9 by 10, but so is the one in the back. So we have two that are 9 by 10, so 180 inches square, right? Front and back. 9 by 10 in the front, 9 by 10 in the back. Let's do the top and the bottom. What are the dimensions of the top and the bottom? Over? Oh yeah, there you go. So top and the bottom, we got a 10 by 8 on the top, on the bottom, and a 10 by 8 on the top. So we have 10 by 8, and there's two of them. So now we have 160 inches square. So we've got the top and the bottom, we did the front and the back, now we just do the left and the right. So what are the dimensions of the left and the right? So we have a 9 by 8. So we have this one and this one over here. Okay? Did I do that right? That's 144, right? Okay. What should I do now? Add them all together. So surface area is add up all the areas of all the sides. So what do you get?
44.
484? So I need to cover 484 square inches, and I have how much to use? Wrapping paper. I have 864 minus 484, which comes out to 380 inches squared left. Is that an answer choice? Oh, I don't like that they didn't put the units. I did it. So 380. A lot of work. Like this is a time-consuming question, but not hard, right? You can think about this. This is real world. You can visualize. If I'm going to cover this, you can visualize what that means. Lots of different skills in this, though. Changing units, finding surface area, finding areas in general, like lots of different skills. Does anybody want this? My work? No? Okay. I like to ask. You want to? All right, look at this nice little house. Look, they drew it for us. All righty. We could try to draw this, but let's not. A building contractor needs to compute the volume of air contained in the building with a rectangular floor as shown in the figure below. Now first, what's volume? How much space is inside? So the volume of this room, how do you calculate it?
Is there another equation for it?
Well, yeah, what's the volume though? There's 3 dimensions. Length, width, and height or depth. It's both the same. So if you picture in this room, if we want to find the volume, if you picture, you've got the area of the floor and you're just figuring out how many of those are stacked on top of each other, which is the height. So we've got a volume. They want to figure out how much air is in this building. It's 20 feet long, 4 yards wide. Oh no, what have they done? 9.5 feet tall on 2 sides and 15 feet high from the floor to the peak. So we want to find what is the volume in cubic feet. So we essentially have this. Well, first, what's one thing you want me to do first? Convert what?
Everything to feet.
Everything to feet. So we should probably change these to feet. And I would make sure I check, because if that was in yards, if the answers were in yards, I might change everything else to yards. But since the answer is feet. So 4 yards, remember, for every yard, there's how many feet? 3. So now we're going the opposite direction, right? We're going to multiply by 3. So this is 12 feet. So now you essentially have 2 things. You have a box on the bottom that is 12 feet by 20 feet by 9.5 feet. So this is the actual house, we'll say. That is 12 feet by 20 by 9.5. So you can find the volume of that pretty easily, right? This whole bottom part. Do you agree? Yeah? Okay. So what is the volume of that? 12 times 20 times 9.5. What do you get?
2,280.
Okay. What shape is the top? A triangular prism. Remember what I said earlier about prisms? Prisms are named for what their bases are. So in this case, it's a triangle. And their lateral faces are rectangles. So you see, this is a lateral face, this is a lateral face, and this is a lateral face. So we've got this triangular prism. What is the volume formula for a prism on your reference sheet? And it's a capital B, right? Volume equals B times H. The capital B means the area of the base. So what shape is the base in this particular triangular prism? Of the roof. The base, so think of it as the ends. What shape are the ends of the roof? Triangles. So then, can we find the area of a triangle? What is the area of a triangle? 1/2 the base times the height. So the area of a triangle is 1/2 the little base times the height. So what is this triangle? Let's just draw our facing forward. We've got a triangle. How long is the base of, how long is this? 12 feet. How tall is this? So you have 15 for the whole thing, 9.5 for this part, so it is 15 minus 9.5, which is 5.5, right? So this triangle up here is like looking at the house straight on. That's my base of my prism that is the roof. So now we've got, this is a lot, right? It's a lot. She's like, I'm gonna skip it. Come back, mark and move on. It is a lot. This is one that would take a lot. But none of this stuff is difficult computation. It's just building it in your mind. I have this piece and I have this piece, so I need to build it. So let's finish the top. So the area of the base is 1/2. What's the base of the triangle? 12. And what's the height of the triangle? Times. So this is the area of the base. Now, the height of the triangle is going to be this, or the height of the prism is going to be this side. You kind of have to think of it as it's sitting like this, like on its end. This is the bottom, and this is how tall it is, 20 feet tall. Okay? So now, multiply that by 20. So it is what? What do you get?
660.
660? Can anyone verify? They also got 660? Okay. And then we just add them together. So 2280 plus 660. $3,940? Nope. 2,940? 3,940. Feet cubed. Just double checking that they are in cubic feet. So a lot. She's like, I'm skipping it. So we found lots of things here. We found the volume of the bottom, length times width times height. And then we had to find the volume of the top by using the area of the base, so that triangle, by how much is stacked up. Questions? Still skipping it, right? Some of you?
Where did you get the 20?
So
I was writing to that.
this formula right here, volume formula for a prism, is the area of the base. So it gets kind of confusing because there's like a base and then another base. So it's the area, the base of the roof. So the roof is a rectangular prism. So if you think of it on its end, the base is it's a triangular prism. Think of it on its end. Like if you were to take that roof and put it on its end, the ends are triangles, right? Then the height of it is how long it is. So that 20, because it was the base of that side of the house. So basically, if you looked at it from the side like you would in a house, if the end was a triangle, the height is how far back it goes to the back of the house. So from the front of the house to the back of the house is the H in this formula. Because you're looking at the triangle from, this is the base of the prism, and it goes this far back. It's like saying, I found the area of this triangle, and now I'm going to stack it and see how many go back for 20 feet. It's a lot.
Yeah.
I could have put like base sub 2 and height sub 2, like all I can put those on there. I can show you again if you want after we're done. Okay, we already did the next page. Now we're moving on to competency 4, which is page 13, number 33. How many of you are putting a sigh of relief now when you see this question?
Yeah.
You're like, I can do this. Okay, what's the mean? How do you find the mean? Add them up and divide by how many there are. So, what do you get? 11. You just add them up, 2 plus 2 plus 6 plus 12 plus 16 plus 19 plus 20, and divide by 1, 2, 3, 4, 5, 6, 7. Yep.
So you were mentioning earlier, like you have a 4-function calculator. Is that like these calculators? What you mean by that, or?
Can I look something up? Yeah.
I think I looked at it and it's pretty much, yeah. It can't, literally it's like the most basic of basic. It can't do anything square root. It can only do multiplication, division.
It's like
addition,
these.
subtraction.
Oh. You remember those calculators from like you were a kid?
Yeah, they never work.
They're solar, so that's another. Oh gosh, I don't want to do that. Really, $58 for how many? 108. Okay. I was like, are you kidding me? Like 108 of them. They have a solar panel thing here, so make sure if you get them, you're not covering the solar panel. But it looks like that.
So, okay, so that's what we were asking, it's like we wanted a hand calculator for that.
Yeah.
That's why. Cause I was hoping it was one of these, just because, you know, you could put the numbers
Nope.
in and just.
You don't get to see a string of numbers or anything. It's just 5 plus 3. Yeah. All right, 14. Number 34. This is what I was talking about earlier, in terms of skewing the data. All right. If a company would like to give the impression that its employees are highly paid, which salary statistic should it use? So let's just look at those salaries. Remember what I said earlier. What do we notice here?
Company gets paid a lot more.
And that means it's a what? That is a outlier. Outliers affect what? The mean. So without even calculating anything, it's fair to say that they probably want to use the mean because it's going to be higher. Because look, most of the people make how much? Who works? $15,000. They're laborers.
Oh, I should cancel all of them.
So most of the people make $15,000. But if you calculated the average, do you even need to? Who would want to? Who would still do it? Would any of you still do it? Well, what's the mode? 15,000. What's the median? Even if they're not in order, if you just switch the 40 and the 60, the median's going to be somewhere in between. What? Oh wait, is the median 15? Oh, the median is also 15. So
And the
you're
minimum?
probably safe, and the minimum is also 15. So you're probably safe to say it's going to be the mean without even calculating it. Especially because they said they want to give the impression their employees are highly paid. Did anyone calculate it? I'm just curious.
Yeah, I did actually.
What is it?
It came out to 40,000.
Like 40,000?
Yes.
So they're going to say the average salary in our company is $40,000. Come work for us. But sorry, you're an unskilled laborer. You're going to make $15,000, and I, the president, am going to make $120,000. No, not fair. So, mean. Keep looking for those outliers. All right, 35. 8 pumpkins were picked from a garden. Very nice. Their weights were 8 pounds, 3 pounds, 7 pounds, 16 pounds, 8 pounds, 13 pounds, 12 pounds, and 1 pound. How much greater than the mean was the heaviest pumpkin? So you have to find the mean, right? And then subtract 16. So what is the mean? So you're going to do the mean minus 16. Sorry, it'd be the opposite.
Yeah.
16 minus the mean. 8.1?
8.5.
8.5? So you get?
7.1.
Just computing things. But remember what I keep saying about the competency numbers. What number is this? 4. This is competency 4. So this is toward the end of your test. So if you've spent too much time on the earlier ones and you're running out of time when you get to this, you might not have time to do the computation. So this is why that marking and moving on is important. All right, number 36. A child has 26 pennies, 15 nickels, 21 dimes, and 18 quarters in the coin bank. When the child picks up the bank, a single coin falls out. What is the probability the coin is a quarter? So remember what I said about probabilities. Probability is the number of favorable outcomes. So in this case, the number of them that are quarters over the total number of outcomes. So how many total are there? How many coins total?
80.
So there's 80 coins. So the probability of a quarter is 18 over 80. And I like that they want you to simplify. How do you simplify a fraction?
Divide by common.
Divide by a common or a common factor. So 18 and 80 are both divisible by what number? 2. So you get 9 over 40. Now, I want to take a second and talk about compound probabilities real quick, because you're more likely to see those. So, compound probability is the probability of the first event times the probability of the next event. And on and so on and so on and so on. So if I said, say I have this same group of coins. I have 26 pennies, 15 nickels, 21 dimes, and 18 quarters. Okay? So again, 80 coins. And I say, what's the probability of a penny? Then the probability of a dime with replacement. And the with replacement part, Matt, oh my gosh, you had a question mark. Wow. The with replacement part is important. So we're going to do probability of a penny times the probability of a dime. So penny, there are 26 pennies out of 80. Dimes, there's 21 dimes out of 80. Now, why did I put the denominator was the same?
Because you replaced the
Because
one
I
that you took out.
replaced it. And that's a key. I took it out the first time, so I drew one in, got a penny. Yay! Put it back in. So now there's still 80 in the second time. So multiplying fractions, just multiply across top, multiply across the bottom. 26 times 21 is
546.
and I'm not going to simplify, I'm just going to do it for that for now. Okay? Now, let's do the same thing. Probability of a penny, then a dime, without replacement. So now, it's still probability of a penny times probability of a dime. Still 26 out of 80. 21 out of 79. Notice how the denominator, when you did not replace, goes down. What if it was the probability of a penny and then a probability of another penny without replacement? The numerator and the denominator would go down by 1 because there'd be 1 less of each. So what's 80 times 79? Just to see what the difference is.
63.20.
So slightly different. Okay, cool. 37. A consultant uses the following graph to justify why air conditioning costs were higher in 2014 than 2015. What aspect of the graph makes it misleading? I want you to take a second, look at this together, kind of discuss it, and I'll be right back.
I get the link in my name.
Okay, so what makes it misleading? You got it? Do you guys notice that?
No.
It's vertical. You didn't notice it?
No, she knows just that I didn't. I'm looking.
Well, look for those kind of things. Look for, they really should put this, yeah, this little guy, that tells you there's a break in the graph, like it doesn't start at 0. Notice how, just look at them. So they're talking about number of days above 80 degrees. They're only the difference of like 1 to 3 days, right? They're trying to say air conditioning costs were so much higher than 2014 than 2015, but you're only talking about 2 additional days that were above 80 degrees. So the vertical axis, so look for those things. Look for the scale, look for what starts with, all that kind of stuff. All right, number 38. Median is what? Middle. What's the key?
Least to greatest.
Order from least to greatest. You can write them out. And then cancel them. So if it's between 12 and 14, it is 13.
Or could you add the 2 and divide it by
Yeah,
2?
exactly. Because if it's
It's not
obvious
two
when it's so
numbers.
close.
Yeah,
But if it
two
was
numbers
like
that aren't next to each
between
other.
45 and 320, I don't expect you to know what numbers exactly in between those two. So yeah, you can add them up and divide by 2. All right, 39. A basketball coach would like to know the total number of points the team scored in a 15-game season. Which of the following measures would provide the coach with additional information needed to make this determination? So what information do we need to know what the total number of points are scored in a 15-game season? All the scores would be helpful, yes.
Yeah.
Would the range tell us anything?
No.
No? Would the median tell us anything? If I said the median score was 36, does that say anything?
No.
Would the mode tell us anything? No. So therefore it is? Why is the mean, how could the mean be helpful? Because it's the average. How do you find an average?
Add them all up, divide by the number.
Add them all up, divide by the number. So if I say the mean was 45, you could just do 45 times 15 and now you get the total. You basically do the opposite. It's not stretching it a little bit. Well, it would be not, I don't know that it would be exact, but it would be Well, actually, if you said the mean was the total divided by 15, and that was the average, right? And then you did the average times 15, I guess that would equal T. So it would be exact. We would have the exact one. All right, number 40. The teacher gives a test and knows that the mean is 79 points and the standard deviation is 2. Which of the following is the best interpretation of the result? Median test score is equal to 79. Most of the test scores would read 77 and 81. Half of the test scores are greater than 81. The lowest test score is 77 and the highest is 81. So what standard deviation means, I say it's a standard deviation of 2. That means it's 79 plus or minus 2. That means most of them fall between 77 and 81. Now that's just one standard deviation. So if we're getting into like the standard deviation curve, this guy, if the mean is in the middle, and we say 1 standard deviation, then this is 77 to 81, which actually, just to give you, this represents 68% of the data if they're talking about a normal distribution. If they said 2 standard deviations, it would be between 75 and 83, which is 2 standard deviations. That's just getting into the curve. But that's this 1 standard deviation represents plus or minus 2. Okay, 41. The owner of a roller skating rink needs to purchase women's skates. Have any of you guys, I just spilled water all over myself, watched King of the Hill? So I never watched it when it was on before, and my boyfriend loves it. So we've been watching it again, and it just makes me laugh because there's a part where Peggy has particularly large feet. She apparently wears a 16 for women, which I don't even know that even exists. But she gets upset when they go to a roller skating rink because the guy keeps saying it over the thing. He goes, I need a men's 13. I need a women's 5, the lady she's with. And she's like, and they're like, anyway, it just makes me think of that. So anyway, roller skating rink needs to purchase women's skates. After reading that the mean women's shoe size is 7, the owner decides to purchase mostly size 7. Which of the following statements is true? If true, best supports his decision. The median shoe size is fairly small. The range is fairly large. The mode of the shoe size is equal to the mean. And the mean shoe size is equal to the median. Which, by him saying the average shoe size is 7, so he purchases mostly 7. Which one of these supports that? Do we agree? So if he can say that the mode is also 7, then that supports it. But if he says the average is 7, but the mode is 9, then he's incorrect. He should probably purchase 9. All right. 42. Guys, I know you're probably talking about math, but it's kind of distracting, so let's just keep our side conversations to a minimum. If you have questions, let me know. 42, a marketing company wants to determine consumer attitudes about a brand of soap in a particular city. Okay? Which following groups would make the best survey sample? So in order for a survey to be a good survey, what do we need to know? It should probably be what? Get plenty of people. Your questions should be relevant and unbiased. So if I come up to you and I'm trying to gauge what kind of soap you like, and I say, Which soap do you prefer? This amazing smelling soap of A, or this okay soap of B? Like, that's biased. That's what I'm saying, like, this one's amazing. Which one do you prefer? And she's like, it's like when people say, like, here, smell this. It smells bad. Why do I want to smell that? So, unbiased, a representative sample. So, a large enough sample, but also representative. So, if I were trying to survey USF on something, and I only asked the people in this room, are you guys a representative sample of USF? No, because you're all education majors. For the most part, you're all around the same age. You're all females for the most part. So you're, sorry, sir. But it's not representative. I need people from all kind of age groups, all majors, all genders equally surveyed. So those aren't representative. So let's look at this. If they're trying to go in a particular city, consumers who regularly purchase the product, okay. Registered voters who tend to vote in every election, okay. Residents who are selected using a random process, and employees who work for one of the town's largest firms. So we're trying to determine consumer attitudes about a brand of soap. So which one is the best to sample? The random people. Because what if you ask the A people? What if you ask people that purchase it? They're biased because they like it. There's a reason they purchase it. All the registered voters, well, if you think about the election right now, like that's, not everybody votes in every election, so sometimes only certain demographics do. Employees of the town's largest firm, that's too narrow. So yes, the most random you can get. All right, what about 43? An ecologist takes a 0.05 milliliter drop of water from a stream and examines it under a microscope. That is a very, very, very small amount. 0.05. The ecologist, this is on a microscope, counts 25 examples of a particular microscopic organism. Using ratio and proportion, the ecologist infers that there are 0.5 million of these organisms per liter of water in the stream. Which of the following is the most important assumption that the ecologist makes with this inference? Drop of water was a representative sample. No water evaporated while on the microscopic side. Oh my gosh, that's such a small amount of water. I guess if only a little bit of it evaporated, that would be fun. It'd probably be gone. The organisms were not affected by the microscope light. Okay. All equipment was sterilized after the test was conducted. So which one? A. So wherever he got the water represents the entire stream. So it's not like he's trying to do an organism. So say he's in a stream and there's a dead, decaying animal in the stream and he takes the water right next to that animal. Is that representative? No. But they might do that. If you think about companies when they're testing things and they're trying to tell you something is safe, they're like, it's safe, it doesn't pollute it. But they're checking like 10 miles down the stream versus right next to it. Yeah. Anybody into that ecology thing? All right, cool. Almost done. You will be done if you're taking the test because there's only 40 on them now. But if you pretended you were almost done. So this is a scatter plot, okay? Company's human resources department is tracking the percentage of employees out sick and the relative humidity of the air in the building. We should test this in our office. Or the temperature of the office. Which of the following conclusions can best be inferred along the following data? So if you just kind of look at the graph, you got employees out sick based on percentage, so ranging from 2.5% to 26 or 27%. And you have the relative humidity ranging from 0% almost to 100%. Now, if there's a relative humidity of 100%, doesn't that mean it's raining? Is it raining inside of your building? Are they talking about outside? No, it talks about the air. Not always. I guess it depends on the temperature as well, right? All right, high values of relative humidity cause people to become sick. Okay. When many employees are out sick, the relative humidity tends to be high. Many employees are getting sick from the mold and mildew in the building. The negative effect of overcast sunless days is influencing employees' health. Well, first we can say not D because they say nothing about the light. So which one is it? B. Do we agree? Is that the answer?
Yeah.
Okay, good. So yeah, because look at it. You can't say that it's causal. They're correlated. So they're correlated. The higher the relative humidity, the more people being sick. But they're not, you can't say without any sort of data that it's causal. You can't say it's more humid in here, so everybody's sick. And you can't say C. You could infer it. I probably would. It could be because there's mold and mildew, because the higher relative humidity, the more mold or mildew you might have in a space. But B is the most likely inferred.
The other thing I noticed is that was the only one that has the phrases on the axis, like word for word.
They use them actually.
And it says like 10 words.
Yeah, because the other ones are kind of just an assumption. Like C is just an assumption, which is probably why. It is probably why. I feel like it's why in our office there's mildew and mold, I'm sure.
I feel like I would have maybe picked A then.
You would have picked A,
Just because of the correlation, but I guess it
but
would
they're
say you
correlated but
said
not causal. You can't assume that they're causal.
I did that once too.
All right, last but not least, the mayor of a city, and these are all competency 4, relatively easy, right? At the end. So marking and moving on to where you get to these and you get them quickly, and then you go back and spend their time on the one with the house. People are like, I'm still. That's one of my 11 I'm missing. All right, the mayor of a city announces that there were 50% fewer automobile accidents in this year than last year. Which of the following is the most important additional piece of information needed to properly interpret these results? The total number of accidents each year, the total number of cars registered in the city, the traffic density on the roads where accidents occur, or the number of dangerous intersections that were redesigned? A. Because you could say there are 50% fewer, but what if there were much more people or much less people or something like that? So you need to know A. You need to know the total number of accidents to get an idea of whether this is significant. All right. Thank you for coming. We are early. Sorry, this is actually nice for me to know that on my express session I'll probably still be okay. I'm happy to answer any questions you have if you want to stick around. If you want to email me, I'm happy to help with anything. You can email Jordan to get the name of the math tutor. Her name is Kelly. She's really great. She used to teach to be a high school math teacher. She's working on her PhD in math education, so she's really good. Good luck on your test. Let me know if you have questions. If you want to stick around, I will be here. And please make sure you fill out the survey for me and put it in the envelope over there, and have a great rest of your day.
if I were to do at home